everybody, this is Mr. Walsh, and today we're going to go over the review for Unit 3 that has to do with molecules. And so here we're going to go Station 1, and we're going to talk about the bonding. And so here we're going to choose between ionic and covalent. Okay, so a bond between a metal and a non-metal, that's ionic. I'm just going to put I here. Okay, and then bond between two non-metals, that's covalent. A bond formed from overlapping valence shell. Overlapping is co, and valence is valence, so that's covalent. Has a low melting point. So if you remember, we did a lab where we compared the physical properties of ionic and covalent compounds, and the low melting point ones were covalent compounds. Things that conduct electricity in water, that's ionic. Okay, the bond created when a positively charged ion is attracted to a negatively charged ion, that's ionic, right? Ion. When hydrogen bonds with chlorine, so this is a non-metal, and this is a non-metal, and so that's going to be a covalent compound. The sharing of electrons, that's covalent, and the transfer of electrons is ionic. Okay, now, here we have how an ionic bond forms. Just so you know, you're going to see a picture like this right on the test. Okay, so you're going to have to know what's going on here, that this electron is being transformed. Okay, so when sodium loses an electron to form an ion, what is its charge? Okay, sodium loses an electron, form an ion with what charge? So it becomes 1 plus. It loses an electron, it becomes 1 plus. If chlorine gains an electron, that becomes 1 minus. What is the positively charged ion called? Positively charged is the cation ion. So a little bit of vocabulary here at the bottom. And negatively charged is the anion. Okay, so now we're talking Lewis symbols. Remember, Lewis symbols is just for elements. Okay, elements. So the octet rule is that elements want to have 8 electrons in their outer shell. Okay, so that's the octet rule. And said which element is stable with just 2 valence electrons. Okay, hydrogen is the one that we talked about, but also helium, even though we haven't talked about it much, helium is also stable. So both of those are an example of that. Okay, and so now for question 3, we need a periodic table. And using the periodic table, you can see how many electrons do each of these elements have. Okay, so aluminum, group 3, so it has 3 valence electrons. So, aluminum is in group 13, so we look at the ones place. Sodium is in group 1, so it's 1. Fluorine is group 17, so that's 7. Beryllium is in group 2 here, so 2. Neon is in group 18, so that's 8. Magnesium is in group 2, so that's 2. Helium, okay, so this is the exception here. Helium is in group 18, but it's up here, so that only has 2, because in the first energy level, there's only room for 2 valence electrons. And then chlorine is in group 17, or the halogens, so that goes here. Group, so it has 7 valence electrons. Okay. Now, fairly straightforward question. The dots on the Lewis symbol represent electrons. Okay. And now we're going to use the periodic table to come up with the Lewis symbol of each. And so boron has 3 valence electrons. So we're going to go 1, 2, 3. Neon has 8, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has 1. Oxygen has 6. Oops, I went too far. So 1, 2, 3, 4, 5, 6. Okay, bromine has 7. Helps if I put it in the camera here. 5, 6, 7. Potassium has 1. Phosphorus has 5. Okay. Notice I'm always using the same pattern, starting at the top and drawing dots around. Calcium, start at the top, go around. Okay? So, when metals form ions, what do? Metals will always lose electrons. Okay? And because they lose electrons, they become positively charged. Okay? And then nonmetals, so metals and nonmetals are opposites, so these always gain electrons or they become negatively charged. Okay? You could also say this becomes a cation if you wanted to get real technical. Okay? And this becomes an anion. Okay? What happens when two nonmetals form a covalent bond? They share electrons. Okay? And so that's what is going on here. Lewis dot structures. What is the difference between a Lewis symbol and a Lewis dot structure? Okay? A symbol is for an element. A structure is for a compound. Okay. In a Lewis dot structure, how many electrons are represented by a line? This is also a bond. Okay, a line is a bond, so that's 2 electrons. And so now we're going to draw the Lewis structure. So you guys need to have the steps. Okay, you kind of need to know the steps. Drawing a Lewis dot structure. So HBr, first step, we count valence electrons. It's 8. And so when we draw this, we're going to draw it like this. And then H is the exterior. Let's see, subtract 2 for the bond. Br is the central. The extras go around the central atom. Okay? So now we have NF3. Okay? So we count valence electrons. 5 plus 7 plus 7 plus 7 is 26. So we'll put N, F, F, F. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 18. And so the 2, 4, 6 there, that's 24. So the extras go around the central atom. Okay. So CCl4, we could also name this. Okay, naming is something we should probably remember. This is carbon tetrachloride. So carbon tetrachloride. Okay, that's 32 electrons. Minus 8 is 24. Okay, and then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Good. Okay, SF2. That's going to be 6 plus 7 plus 7 is 20. So S, F, F, minus 4, 16, 2, 4, 6, 8, 10, 12. So we have 4 extras. Extras go around the central atom. Okay. Seems like every time we've done something, we've always had to draw the structure of carbon dioxide. So so this is 4 plus 6 plus 6, 16. We're going to go CO, 2, 4, 6, 8, 10, 12. And so we did 4 for the bonds. It's down to 12. 12 for the extras. We're down to 0. And so carbon doesn't have an octet. We have to make sure that carbon has an octet. So we get rid of this and we put a double bond. And then we get rid of these and do a double bond. So what I'm going to do is I'm going to rewrite this so that it looks a little nicer. Okay, so that I'm not confused. Okay, so that the person grading this knows that this is the structure. The dots are right and everything. Okay. So this is 26 electrons. We'll put P in the middle. I. So that's minus 6. We're down to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18. 2 left over. They go on the central atom. Okay. So, how many electrons are shared in a single bond? 2. Okay. How many electrons are shared in a double bond? So this is 2 lines, so that's 4. In a triple bond, that's 3 lines, so that's 6. Okay, so what does this 4 mean here for question 5? This means that there are 4 Cl atoms in the compound. So how can you determine if a bond is polar? We determine a bond is polar if it's bonded to two different elements. Okay, so that's good. And so what are the two conditions that need to happen for a molecule to be polar? Number one, different different elements on bonds. Okay, and then basically this is the two questions, right? And then the second question is, are there dots? So then dots on the central atom. Okay, and now for this it says, are the following bonds polar or non-polar? Okay, so if it's the same on each side, this bond is non-polar. Okay, HBr, different, polar, polar. Now CH is the exception, so this is a non-polar bond. And this is non-polar because it's the same on each side. Okay, NF, polar, OCl, polar, polar, SH, polar. Okay, so now we're going to come down here. Are the following molecules polar or non-polar? Different bonds, dots, so this is polar. Okay, bonds are different, dots, polar. Bonds are different, no dots, so non-polar. Okay, bonds are different, no dots, non-polar. Bonds are different, dots, polar. So again, you have to have the right Lewis structure. But if we're going to do this, let's see. So this has 3 bonds. So if it has 3 bonds, this means that this is trigonal planar. Okay, I called it flat triangle. Okay, this has 4 bonds. 4 bonds is tetrahedral. Okay, and 2 bonds is linear. Okay, so now this is matching. So we're going to match up bent, linear, trigonal planar, tetrahedral. Okay, so even though we may or may not have talked about bent, we can definitely do linear. Linear is B. Okay, so that one we got. Trigonal planar is C. Tetrahedral is D. Bent is A. Okay, so that's good. And this actually looks. Okay, and the last one here we have is the lab and things like, and some gas law stuff. Okay, so it says determine project describe covalent or ionic compounds. High melting point is ionic. Low melting point is covalent. Conducts electricity, ionic. Non-conductor, covalent. Okay, and it says list the properties and types of compounds of the types of compounds listed below. So again, this is kind of the word equivalent of what we've done before. So this is high melting point, conducts electricity. Okay, some other things that you could say. It's between a metal and a non-metal. You could also say that it's no prefixes when naming. You could say it's a transfer of electrons. So there's a lot of things. Okay, these are the physical properties that we measured, but there's a lot of things that could go here. Okay, so covalent, you can just use the same list and do the opposite. Covalent is low melting point. It's an insulator, the opposite of electricity. A conductor is an insulator. Insulator. It's between two nonmetals. It uses prefixes when naming. Okay, and it's a sharing of electrons. Okay. So now the gas law problems. Okay. So again, we're going to go P1, V1, T1, and then P2, V2, T2. I don't have a ton of space. So occupies a volume of 5 liters. So that's that. Pressure is 750. Okay, what is the volume when the pressure, so the volume, we want to know what the volume is when the pressure goes to 1,000. Okay, so we're going to go P1 V1 over T1 equals P2 V2 over T2. We get rid of temperature because temperature is not part of the problem. Okay, we can either see it here, temperature remains constant, or we can see here that it's not part of the thing. Then we plug it 750 times 5 equals 1,000 times V2. Now we don't need to cross multiply these, so we're just going to divide both sides by 1,000. So now we can do 750 times 5 divided by 1,000. And so that new volume is, let's see. So let's see if I can do it in my head without a calculator. Okay, so 5 cancels this out. This is 200. Cancel this out. So 75 divided by 20. I don't know. And so V2 is 3.75. Okay. And then, you know what? If you get to this point and you need to know what the last one is, come find me and we'll do it, or look at the posted question or the posted answer key. Okay, everybody, have a great day.